A 6-inch black cube promises 4K couch gaming, while an entire industry holds its collective breath over a price tag nobody actually knows. We are tracking Valve's summer 2026 hardware slate for this deep dive, tearing through leaked specs and panicked supply chain reports to figure out what the Steam Machine and the Steam Frame VR headset are going to cost you. The current state of tech journalism trying to cover this impending launch borders on self-parody, actually.
Read that Screen Rant piece published by Angarad Redden to see the hysteria perfectly captured. The headline screams that the Steam Machine official price is nowhere near what anyone hoped for.
You read this massive piece, scrolling past auto-playing video advertisements for car insurance and newsletter pop-ups demanding your email address. You take in claims about how the device runs SteamOS with fast suspend and cloud saves. You reach the final paragraph, expecting the hard number the headline explicitly promised. The author literally writes that they do not know how much the Steam Machine will cost.
Check the comments section under that article for a total bloodbath. User Strago calls it the most misleading piece of content they have ever read.
Oh, wow. Another user named SR Member registered a brand new account just to call the piece a giant nothing sandwich. A commenter named Kenneth states journalism is dead. The media is just desperate for clicks because Valve refuses to drop an official price.
Track the backend database commits instead of reading SEO filler. On May 30, Valve added a welcome tour page for the Steam Machine directly to their backend site architecture.
Wait, people are running automated scrapers on the Steam API to catch those changes.
SteamDB monitors every single alteration Valve makes to their storefront servers. Connect that quiet update to their established hardware launch patterns. When Valve released the Steam controller recently, that peripheral started shipping exactly 2 weeks after its own welcome tour page code went live on the servers.
Valve gave a vague summer 2026 release window in their developer blog, sort of leaving it open. Summer in North America runs strictly from June 21 to September 22.
Pushing production code to the back-end forces that vague seasonal timeline into an immediate reality. Brent Kapp at Vice tracked these exact commits, suggesting a launch as early as late June or July. The hardware is sitting in warehouses right now, waiting for the storefront to update.
If Valve is dropping this hardware in a matter of weeks, the conversation shifts directly to what is actually inside this cube. The massive community hype surrounding a 6-inch box relies entirely on the internal components. We have confirmed specifications from Bruno Ferrera's report at Tom's Hardware, painting a highly specific engineering picture. The Steam Machine packs a 6-core CPU targeting a 30-watt thermal design power, or TDP.
The graphics run on an RDNA 3 GPU featuring 28 compute units clocked at 2.45 GHz, pulling a 110-watt TDP.
Stop me right there.
Thermal design power dictates the maximum amount of heat a component generates that the internal cooling system must dissipate to prevent the silicon from melting. It represents a strict thermal ceiling. The higher the wattage, the more raw electrical power the chip consumes.
That electrical consumption generates immense thermal energy, like a space heater. Your fans and internal heat sinks must physically eject that heat from the chassis.
A high TDP indicates serious computational force, demanding an aggressive engineering solution to keep the system stable. You are putting a miniature furnace inside an entertainment center.
That gives us a massive point of comparison for you listening at home. The Steam Deck handheld maxes out at a 15-watt TDP. Using a device capped at 15 watts feels like walking a pug on a leash. Plugging a 110-watt Steam Machine into your living room TV is like trying to hold on to a racing greyhound. You're cramming a 110-watt powerhouse into a box the size of a grapefruit. Putting a 110-watt chip in your living room sounds like a thermal disaster waiting to happen.
Hardware melts when you pack too much power into a tiny plastic shell. Valve engineered massive custom vapor chambers and directed airflow channels for this specific form factor.
Valve learned a harsh lesson from the acoustic complaints on early Steam Deck models, I imagine. The fans on those early units sounded like jet engines spooling up on a runway.
They route cool air directly over the memory modules and exhaust the 110 watts of GPU heat out the rear to keep the acoustic profile low enough for a quiet living room environment. They use liquid metal thermal interfaces to pull heat off the processor faster than traditional thermal paste.
The 28 compute units on that RDNA 3 GPU act like separate lanes on a data highway. More lanes mean the chip processes complex visual geometry faster, generating immense heat that the vapor chamber must absorb instantly. We have this racing greyhound of a graphics chip inside a tiny cube, but the developer guidelines are telling a completely different story about performance limits.
Valve updated their internal certification process to officially include the Steam Machine and the upcoming Steam Frame VR headset, The mandatory baseline performance target developers must hit for the Steam machine is 30 frames per second at a 1080p resolution.
They publish these guidelines explicitly to ensure a standardized experience across this new hardware tier, I assume. The verified program dictates exactly what consumers can expect when they boot up a new title.
Developers must prove their game runs stably at that resolution to earn the green checkmark on the storefront.
I am completely lost on that logic. Valve is actively marketing this console as a high-end 4K 60 frames per second living room device. You buy a 4K television, you buy a high-end Steam machine, you expect a 4K image. Why are they giving developers a free pass to aim for 1080p when the hardware is pulling 110 watts?
Modern gaming hardware relies entirely on software upscaling. Semi-custom AMD desktop class chip requires technologies to reconstruct the image from a lower native resolution.
Rendering every single pixel in true 4K destroys frame rates, even on flagship desktop graphics cards that cost $2,000.
The game engine renders the internal geometry and textures at 1080p. The hardware uses temporal algorithms to guess what the missing pixels should look like, outputting a fake 4K image to your television.
The algorithm analyzes the previous frames of motion and injects new pixels to fill the gaps. You save immense processing power by rendering a smaller image and letting the silicon do the math to stretch it out cleanly. Instead of drawing 8 million pixels, you draw 2 million and let an algorithm color in the rest.
The 1080p at 30 frames per second metric operates strictly as a minimum guarantee. It serves as the absolute floor a developer must cross to get the verified checkmark on the Steam store.
That baseline ensures the game is functionally playable without forcing the hardware to rely entirely on aggressive, resource-heavy upscaling algorithms just 1080p natively. The upscaled 4K output becomes a blurry, artifact-heavy mess filled with ghosting and shimmering textures.
Upscaling needs a clean foundation to work properly. Keeping that upscaling clean requires massive memory bandwidth.
The global silicon crisis ravaging the tech supply chain severely bottlenecks that bandwidth. Reports from Jib and Joseph at PC Mag point to a severe memory shortage delaying these hardware releases for months. Artificial intelligence data centers are slurping up every available RAM and NAND chip on the planet. Large language models require massive arrays of high-bandwidth memory to process trillions of tokens. Buying PC hardware right now feels like trying to buy a single bottle of water in a desert, while a tech billionaire drains the oasis for a server farm.
AI companies buy silicon wafers directly from the foundries before they are even cut into consumer chips. The gaming industry fights over the scraps left behind.
The real-world financial impact of that supply shortage forces a fundamentally different pricing model for Valve's consumer hardware. Insider Gaming's executive editor Mike Straw reported internal rumblings confirming the final retail price is nowhere near Valve's original $600 to $800 plan.
Developer Brad Lynch corroborated this shift. 2 months ago, internal price estimates for the console were already significantly higher than current Steam Deck retail prices.
Valve enacted a massive, unannounced price hike on their existing hardware inventory to compensate for the memory costs. The Steam Deck OLED 512GB model jumped from $549 to an eye-watering $789. Higher-tier models are currently hitting $949.
Silicon inflation hits the consumer directly.
That is terrifying. If a handheld device containing older, lower-spec components requires a $950 price tag to manufacture and sell profitably in the current market, the higher-end Steam machine will clear the $1,000 mark instantly. Sony is an established, dominant living room giant, and their PlayStation 5 Pro is currently sitting at $899. Microsoft abandoned the high-end console race entirely. Valve is asking you to break the $1,000 barrier for a PC console hybrid during an unprecedented global component shortage. I refuse to pay $1,000 for a box when my existing computer plays the exact same games.
Drop $1,000 on a Steam machine, or invest similar capital in the upcoming Steam Frame VR headset to rival the MetaQuest, and you find a radically different value proposition. The exorbitant upfront hardware cost is effectively subsidized over the lifecycle of the device. Buyers avoid the standard $70 console game tax entirely.
Sony and Nintendo lock you into their closed ecosystems, forcing you to pay premium prices for proprietary software. Steam's massive digital library and frequent discount sales offset the initial pain of the hardware purchase.
Pay a premium for the physical box, but pay drastically less for the software library over the next 5 years. You trade hardware margins for software savings. Valve takes a 30% cut of every game sold on their platform.
They do not need to make massive profits on the hardware itself. You're making a huge assumption that anyone will actually be able to buy this machine at retail device, though. The wildcard factor destroying that ecosystem math is basic supply and demand. The $99 Steam controller launched last month, and scalpers flooded eBay, demanding $300 or more for a basic peripheral.
Bot networks bypassed the purchase queues in seconds. Forum users tracking this launch are already doing the grim retail math on the Steam machine.
Commenter The Striker observed that newly manufactured laptops with equivalent hardware capabilities, like the MSI Claw boosting 32 gigabytes of RAM and a 1 terabyte solid-state drive, are currently pre-ordering for $1,700 at Best Buy. Another user, Hotaru251, is predicting a $1,200 to $1,500 launch bundle for Valve's machine, arguing that standard consoles are already pushing $1,000. The fear gripping the community is not just the base retail price. The real terror is whether Valve can manufacture enough physical units during a memory drought to beat the secondary scalper market.
Valve cannot outmanufacture the current silicon deficit. Even after bumping the price of the Steam Deck to $949, the hardware instantly ran out of stock.
The AI industry absorbs too much raw material.
Launching the Steam machine means stock will vanish in seconds, and bot networks will snatch up the remaining inventory. The eBay listings will dictate the actual market value of this console. Consumers will face a secondary market demanding $2,000 just to access the hardware.
If artificial intelligence server farms continue to consume the global supply of memory chips at this accelerating rate, high-end PC gaming hardware might soon transition from a mainstream hobby into an exclusive luxury good available only to those willing to outbid a corporate data center. Goodbye.